Alright, so today you guys should have just finished an activity where you drew some pictures using Skittles to help you visualize a couple of these different reaction types. And right now I just want to go through a couple examples that are found in the back of your notes. So if you don't have your notes out yet, get them out now. We'll go through a few examples towards the end of your notes where you have to first of all decide what type of the reaction it is. So either it's going to be synthesis, where you have stuff coming together, synthesizing, or decomposition, which is the opposite of synthesis, where you have something breaking apart into pieces, or single replacement, where you have one thing coming in to replace a similar thing in a pair, kicking somebody out, or double replacement, where you have two pairs and it's like square dancing where the partners are switched, or you have combustion, which was not in your Skittles lab, but that's where you have a carbon-based something that mixes with oxygen to make water and carbon dioxide. So that's the first thing you have to do, is decide what type this is going to be. And after that, you're going to complete the reaction by filling out some products. So trying to guess what's going to be on the right side of the arrow. That's the tricky part. And then you're going to balance. So for example, our first example, we've got a carbon-based compound that's mixing with oxygen. That's an example of combustion. With combustion, you always have the same two products, carbon dioxide and water. Doesn't matter which order you put the carbon dioxide and water, but those are always the two products. So now I've done steps 1 and 2. Now step 3 is just to balance. Let's do carbons first. On the left I have 6 carbons. On the right I only have 1, so I better put a 6 in front of that CO2. Now let's check my H's. Over on the left I have 12 H's. On the right I have 2, so I better put another 6. So 6 times 2 gives me 12. So now my C's and my H's are all set, but of course my oxygens are left. They're always the hardest. On the left you have 6 O's and 2 more. That makes for 8. And on the right you have 12 O's plus 6 more. You actually have 18. So we're going to have to get from 8 to 18. So what I would do is try to mess around with this O2 over here, because if I mess around with the O6, it's going to mess up my 6's and my H's. So it turns out that if I put a 6 in front of my O2, that'll give me 12 O's plus 6 more, which is 18 O's altogether. 18 O's on both sides. Tricky. So if I double check, 6 C's, check. 12 H's, 6 times 2, 12 H's, check. And then if I add up all my O's on the left, I have 6 plus 12, 18. And on the right, I have 12 plus 6, 18. Tricky one. Next one, H2 and O2. If I stick these two together, they're actually going to just come together as one. They're going to synthesize in a direct relationship like that. I know it cannot be a decomposition because it's not one thing splitting. I know it can't be single replacement or double replacement because there are no pairs. It has to be a synthesis. So when H and O come together, there are a couple different things that can happen, but let's just go ahead and say that it makes water. I think that's the easiest pairing up of H's and O's. So we'll just say it makes water. Now as I go to balance these guys, I'll see 2 H's on the left, 2 H's on the right, all set. But my O's I'm going to have to balance. 2 O's on the left. Let's make 2 O's on the right by doubling. But now you've messed up your O's, or you messed up your H's actually. So double check. On the left we have 2 H's, and on the right 4 H's. So let's change the left side. We'll go from 2 to 4 by putting a 2 in front. Now you've got 2 times 2, 4 H's on the left. 2 times 2, 4 H's on the right. And let's double check. 2 O's on the left, 2 O's on the right. We're all set. Let's try another one. Zinc and lead nitrate. Now this one is going to be our first single replacement of our set. I know it's going to be single replacement because my zinc is solo and my lead and nitrate are in a pair. If you see a solo and a pair, you can assume it's going to be single replacement. Zinc and lead nitrate. Zinc, just Zn. Zinc is not a part of my special 7 that needs a double. It can just exist by itself. And then lead nitrate, Pb, is going to be plus 2 in this example. You can see by the 2 in parentheses. Nitrate is NO3 1 minus. You're going to have to crisscross. The plus 2, whoop, crisscrosses over to the nitrate, and the negative 1 with the nitrate just gets ignored. So now when zinc comes in to replace Pb, it's pretty nice. Zinc has a plus 2 charge just like lead does. So when zinc comes in to replace Pb, it'll be Zn with a +2, nitrate with a -1, so they'll crisscross the same as lead nitrate with the +2 from zinc, whoop, crisscrossing over to the nitrate, and then -1 from the nitrate just gets ignored. And then Pb is left alone in the dark, gets kicked out, and Pb is again not one of the special 7 that needs a double. So at this point, you've done your prediction, which is the trickiest part, and now to balance, we get a nice surprise. 1 zinc on the left, 1 zinc on the right, 1 lead on the left, 1 lead on the right, 2 nitrates on the left, 2 nitrates on the right. We are all set. Let's try a few more just to make sure you're feeling okay. Magnesium chloride and silver nitrate is going to be our first double replacement. We'll see 2 pairs here. Don't forget about your crisscross. Magnesium chloride, magnesium has a +2 Cl and -1. If I do my whoop whoop crisscross, MgCl2. Again with silver nitrate, silver has a +1 nitrate -1. A +1 and a -1 crisscrosses and is canceled. So with all of these, surprise, you're going to have to worry about crisscrossing. Whenever you have double replacement, you're going to always have a bunch of +- pairs, so you're going to need to crisscross. Over on the right, we've got to figure out how these guys trade partners. And if we remember that we always need a plus and a minus in a pair, it's actually pretty easy. Magnesium was a +2, silver was a +1, so they can't come together. We can't have a plus and a plus. So that must mean we're going to need Mg to pair with the nitrate, +2 and a -1. And I'm going to need silver, the +1, to pair up with my chloride, -1. So Mg with its +2 crisscrosses with the -1 of nitrate, whoop whoop. And then silver and chloride, silver has a +1, chloride has a -1. They crisscross and cancel. You always want to write your plus before your minus, just like on the left-hand side you would, which is the only tricky part of these. So magnesium was first on the left side, so it should be first again on the right. And you'll see silver was first in the pair on the left, so silver should be first in its pair on the right. So now that I've predicted, the last part is to balance. This one's not too bad. On the left you see 1 magnesium, on the right 1 magnesium. Chlorines, you'll see 2 on the left, only 1 on the right, so let's double the 1 on the right. Silvers, you see 1 silver on the left, 2 silvers on the right. Oh, that's okay, we'll just double the silver on the left. And then nitrates, you've got 2 nitrates on the left, 2 nitrates on the right. We're all set, but let's just double check. 1 magnesium, check, check. 2 chlorines, check, check. 2 silvers, check, check. 2 nitrates, check, check. Alright, moving on to potassium and copper sulfate. This one's going to be a single replacement. Potassium is solo, coming in to kick out somebody in the happy pair of copper and sulfate. Potassium's just K, it lives by itself. And then copper sulfate, try to predict this one. Copper has a +2 charge, sulfate, SO4 2-, so the +2 and the -2 cancel. And you've just got K plus CuSO4. Now potassium, we've got a single replacement, is going to come in and kick out copper. Copper can exist by itself, that's fine, doesn't need a 2. But then potassium and sulfate, they're going to pair up a little different with their crisscross. Potassium has a +1, sulfate SO4 2-. You're going to have to crisscross with a whoop whoop. The SO4 sends its 2-, whoop, down by the potassium. Now that you've done your predicting, it's time to balance. Not too tricky for this one either. Check your potassium. 1 potassium on the left, 2 potassiums on the right, so we better double the potassium on the left. And then if I check my coppers, 1 and 1, check, check. Check my sulfates, 1 and 1, check, check. So you're all set. So the trickiest part you can see with these is kind of predicting with the crisscross method what the pairs are going to look like. Next one, lead nitrate and HCl. This one's going to be another double replacement. You've got a couple pairs going on. Lead 2 nitrate plus HCl. Let's see, lead with a 2, that means it's going to be Pb with a +2 charge. Nitrate, NO3 1-, so when they crisscross, the Pb's +2 gets whoop, scooched over by the nitrate, and the nitrate's -1 gets ignored. HCl was already given to you, so that's kind of nice. So now double replacement I think is the trickiest, because you have to remember that the pluses and minuses always go together. So when pairs get traded, my Pb, which is a plus, cannot go with my H, which is a plus. My Pb that's a plus is going to have to go with the Cl that was a minus. Same with your nitrate. Your nitrate, which is a minus, can't get paired with your Cl that's a minus. has to get paired with the H that's a plus. So Pb plus 2 is going to get paired with Cl minus 1, crisscross, whoop whoop, PbCl 2. And then your H, which is a plus 1, gets paired up with your nitrate, which is a minus 1, whoop whoop, and they cancel. So now let's try our balancing, not too tricky. Pb, I've got 1 on the left and 1 on the right. Nitrates, I've got 2 on the left, ooh, only 1 on the right. Let's double the 1 on the right. H's, 1 on the left, 2 on the right. Ooh, we're going to have to double your HCl to make up for that. And then Cl is left, 2 Cl's on the left, 2 Cl's on the right. You're all set. So to double check, 1 Pb, check, check. 2 nitrates, check, check. 2 H's, check, check. 2 Cl's, check, check. A couple more. Sodium and HOH. This one is going to be a single replacement. Your sodium is solo coming in to replace the hydrogen in HOH. Again, the sodium, which is a positive, has to come in and replace something like it, another positive. So we'll take out the positive H. So sodium is just Na plus HOH. Sodium is going to come in and kick out the H. Now H cannot exist by itself. H has to exist as H2. And the new pair now is Na with a plus 1, OH with a minus 1. Their charges cancel, and H, again, can't exist by itself, has to be H2. So now when I check my balancing, this one's a tricky one. Na's are even, but my H's are not. Now you've got 2 H's on the left and 3 H's on the right. When this happens, what I like to do is try to make an even number on this weird odd numbered side. So I'm going to double the NaOH. This way I have 4 H's, which is something that could happen over here. If I have 3 H's over here, I can't really fix that with an even number, so I try to get an even number on both sides. So 2 NaOH, that means I'm going to have to double my Na on the left, and I'm going to have to double my HOH so that my O's match. So this one's kind of a weird one. You have to do a little guess and check. Now let's go back and check. 2 Na's on both sides, check, check. 4 H's on the left, 2 plus 2, 4 H's on the right, and then 2 O's on the left, 2 O's on the right. That was a tricky one. Ki, this is our first example of a decomposition one. This is kind of a weird one. So I've got K and I that are paired together, and these guys are going to break apart into K and I. Now if I double check my periodic table to see if K or I is a part of the special 7 that needs a pair, K is not. K can exist alone, but I has to exist as I2. It's one of those special 7 that needs a buddy. So since my I is doubled on the right, again, that's from your periodic table, one of the special 7, I'm going to have to double my Ki on the left, so I have 2 I's on both sides. Now that's messed up my K's. 2 K's on the left, better get 2 K's on the right. Check your I's, 2 I's on the left, 2 I's on the right, you're all set. And then the last one over here is another single replacement. Calcium's going to come in and kick out somebody in a happy pair. It's going to kick out the lead because calcium's positive and lead is positive. The positive things replace each other, just like in double replacement too. So calcium just exists alone, Ca, and then lead nitrate, you're going to have to crisscross. Pb has a plus 2. Nitrate has a minus 1. You're going to have to do a whoop whoop. So Ca plus Pb, NO3, and then the 2 from the Pb plus 2 gets whooped down by the nitrate. If we predict the products, calcium's going to come in and kick out Pb. So calcium will be with your nitrate now. So double check your charge for calcium. And you're going to see that calcium also, just like lead, has a plus 2 charge. So Pb is solo now, got kicked out, and calcium with a plus 2 charge is paired up with your nitrate with your minus 1 charge. You still have to crisscross, so your plus 2 goes whoop over by the nitrate. Trickiest part about these is to predict and to remember to think about crisscross. Once you've crisscrossed, let's double check our balancing. 1 calcium on the left, 1 on the right. 1 Pb on the left, 1 Pb on the right. 2 nitrates on the left, 2 nitrates on the right. Awesome, all set. So this should hopefully give you some examples so that you can start your homework. So today you should have already turned in your Skittles lab. Make sure you've done that. And then your homework tonight is a half sheet you should pick up from the front counter called Identifying Types and Balancing. It's going to look a lot like these examples you just did. Hopefully you guys will be back tomorrow. Sorry to miss you guys again. Tomorrow what I'll be checking is your Chapter 8 note packet to make sure you've got that filled out via these lovely videos that I'm sure you love. I'm also going to be checking your balancing practice homework from the weekend. It was that blue half sheet. Answers are posted on Moodle if you want to check your work. And then also this identifying types and balancing white half sheet that you're going to pick up today. Thanks again, you guys, for having such great attitude with having a sub. It sounds like you guys have been doing great so far. Thank you so much. Hopefully I will see you soon.